Look at that jiggle.
Look how big that quad's like this.
I think that's the opening line of the video. Look at that jiggle. Okay. So, hello.
No pins.
Today we are learning about
He's in his underwear.
a tool called U substitution. It seems tricky at first, and then when it clicks, you're good to go. So just be patient with yourself, okay? We are going to page 10 right now, okay? So page 10, you ready? You ready?
I'm ready, guys.
Here we go.
Page 10, yeah, I'm ready.
Whenever you have something that you can't easily integrate, remember, we don't know.
I feel like we did one of those in the homework class.
A version. Shh. Trust me, you're going to want to pay attention today.
All right. I'm locked in.
Are you paying attention today? It's not giving paying attention. Okay, so if we do a product rule and a quotient rule to find the derivative, we're like, okay, I see like two things being multiplied together. I see a quotient of two functions. I know I'm going to use the product rule. I know I'm going to use the quotient rule, bada boom, right? But in integrals, there's no opposite to go backwards to that. You don't know that, and you don't learn that until next year when you learn integration by parts, okay? So if you ever see things being multiplied together or quotients, you can either try to rewrite them into singular power, so you can use the reverse power rule, or you can expand. I think some of the problems from the homework last night, you were like, oh, I got to expand this out because I don't know how to do this, right? Allow me to offer you an alternative here, right? So if I have something that looks like this, could I expand it out? Sure. Is that kind of a lot of work? Yeah. So let's use our knowledge of the chain rule, a tool called U substitution, and this is going to help us kind of integrate stuff that's tricky looking, okay? So let's go back to our old tools back in the beginning of when we first learned the chain rule. When we first learned the chain rule, we wanted to identify the clear inner function. What would be the clear inner function here?
X4 plus 1.
There you go, like riding a bike. So we're going to let U equal x to the fourth plus 1. Okay? And now, when I take the derivative of this in order to find du, you're going to have a 4x to the third, and then don't forget your dx. You just took the derivative with respect to x, okay? So now, look at the original. In the original, do you see any of the pieces from du present?
Yes.
What do you see?
No, wait, no.
X cubed. Okay, that's one of them, right? What else do you see?
GX.
Yeah. What about that 4, though?
Nah, one is in the exponent.
That 4 is not there. So let's divide both sides by 4. Remember, you can pull a constant out of an integral, no problemo. Now is everything spoken for in the original integral? Yeah, and what do you do with that 1/4? You put that 1/4 out front. And why did we bother doing this? So we could rewrite this in a form that's way easier to integrate. So let's use u and try to integrate that way, okay? So we're going to use u and rewrite this in terms of u. Now look, take 2 seconds and look. Where did everything come from? Just look at the board. Just look at the board and see where everything came from.
From Mark.
Uh,
Yeah.
You.
Came from Jason.
What?
Something out.
Came from Jason.
Do you see how everything is spoken for in there?
Yeah.
We just rewrote it in a different form. That's all. That's all U does. It's a little tool that helps us make stuff easier, right? So now if I wanted to integrate this, it's so easy. I would just write it like this. And now I get to use the reverse power rule. Yahoo! I have a 1/4 out front. I have u to the 1/2, and I'm going to add 1. When I get that new exponent 3/2, I would divide it by 3/2, right? Division by 3/2 is the same thing as multiplication by 2/3, right? Okay, so now I've got, these are going to kind of cross reduce here. Oop, don't know what that line thing's from. 1/6 u to the 3/2 plus c. Don't leave Connor in the car. It's not safe in there for him.
Ching bong.
Okay.
What about du?
D's nuts.
When you integrate, both the integral symbol and the differential disappear. They'll make more sense when we get to
Okay.
Riemann sums and definite integrals. Right now, just hang on that they're a part of the notation. Okay? Hmm?
The x cubed, you said 1/4 is x to the dx.
Yeah, so when we rewrote a du in there, what was du really? Those two things. So this du is x to the third dx.
You don't have to write x to the dx.
No, because then like, how is the u making anything really easier, right? Good questions.
It just disappears.
So think about it, right? If you take the square root of 64, what do you get? Square root symbol disappears, right? You've done the operation, the operator is gone, and what do you get? Right? So when you integrate, this and this disappear, and you're left with the original. Okay? These are good questions. I can tell you guys are trying to make sense of this. So at the end, I don't want to give my answer in terms of u. I want to give my answer in terms of x's, right? So now I'm going to go back and substitute. Come on, Duffy. Woo. No, it just won't let me scroll at all. Okay, so now I have, can you guys just tell, oh, it's working now. X to the fourth
Oh.
plus 1.
Nah.
You don't have to, but if you did, what would it simplify to? Do you guys remember?
That over 6 to the 3.
Zoo-wee-ma.
I don't like that.
Right? You could do it like that. You could do it like that.
Boo.
Right? Yeah.
I
yeah.
feel like the other one looks more simple.
Whichever one you want.
I like the first one better. I like the second one. Gone when we're fighting.
Whichever you'd prefer.
Your
Okay?
pen's kind of getting freaky.
Honestly, I prefer the first one, where it's like the last part. But like the third one looks nicer than the second.
This is the easiest one to solve,
Yeah.
but
Man, we don't
see,
need
it's all in the
solid.
eye of the beholder, right? Now, don't you dare freeze on me, you little rascal. Hold on. I might have to stop the video.
Why? What?
It's because it's like it's too much going on. It like won't let me scroll and
Gabe.
stuff. All right. It's not Gabe's fault.
Yay.
Do you hear this, Gabe? They're blaming you. Okay, so let's go to the next page and we're gonna do some more problems. Okay. Look at this one. Woo! What is usually the outer function and what's usually the inner function? So E is usually the outer, and then the exponent is usually the inner, right?
There's a lot of X.
When you look for your u, you're looking for u's derivative as well. When you look for your u, you're looking for u's derivative as well. So, do you notice that if this was u, this is u's derivative?
No.
Oh, I see it.
Yeah. Yeah, wait till you see it, right? You want to look for u such that you can also see u's derivative in the original, okay? So, I'm going to let u equal x to the third plus x squared. So when I find du, that was the exponent of e.
Why
So when
is
I
there the one in parentheses?
because you'll see where he comes from. Check it out. When I take the derivative of x cubed plus x squared, I get 3x squared plus 2x dx. Is that not this and this?
Yeah.
That's what I mean by look for u such that u's derivative is also present. Because now the du is going to encompass so much extra stuff if you can find u's derivative in there.
I'm curious if you took why we're finding the derivative.
Yeah, why
We're
are
trying
we
to find
finding
the
the derivative?
reverse derivative, which is the integral.
Because think about when you find the derivative of, so if you start with e to the x to the third plus x squared, that's like your original, right? Then you find his derivative. So it would be e to the stuff times the derivative of the stuff. So this is the derivative. Remember, we use integration to work backwards from the derivative and find the original. When I integrate this guy, right, I want to think about the derivative that crops up, the derivative of the inside, because then I let him equal du, and then I get back to my original. So you're trying to find the original. In finding the original, you also have to find the derivative that it gets multiplied by at the end, right? You have to find the derivative of the stuff, pretty much, because that's going to kind of disappear when you work backwards.
What?
It's a really good question.
What?
Yeah? Think about it. This is the original. This is the derivative.
How do we know
When we
this?
integrate, we start with the derivative and go back to the original. That's why you have to look for the times the stuff, the derivative of the stuff.
Oh.
Okay.
It's E.
Yeah, exactly. You guys are asking such good questions. I'm so glad this is on video.
Elvis.
Good job. Good job. Okay. E for Elvis. Sure. So now, if I had to rewrite this in terms of U, why do I write it in terms of U? Because it's way easier to integrate. I would have e to the, go ahead, who's feeling brave?
E to the U.
E to the U,
E to the other.
du, right? Don't forget the du. And then just check, oh yes, and then just check if everything is present, right?
This is European.
Okay, so this was spoken for by this was spoken for by this, and then the u was spoken for by this. I'm good. I'm ready to integrate, okay? So then when you integrate, you just get e to the u plus c. And then wasn't this the original that we were talking about, right, when we were trying to answer Eleanor's question? Yeah, right?
Sure.
Cool. Okay. Yeah, right? You got it. Yeah. Okay, let's keep going.
Ooh, that was a spicy one.
Okay. Mr. Spicy Fart, would you like to identify the inner function for us here?
X squared plus 1.
X squared plus 1. Okay.
That's all these.
And then let's go around the room. St. John, what would be du then? What do you think?
2x.
Don't forget the dx. Good job. All right, Chase, write it all together for us in terms of u. The hardest part. Ready, go.
I believe in you.
Would you like to pass to Connor since you weren't here? Connor, go ahead. Rewrite the integral in terms of u for us.
Oh. Okay. So basically, you go u
Uh-huh.
squared.
Yeah.
Yeah. Times 2x.
No.
No.
That's going to get taken up by the...
Oh, right there. I didn't see you.
Woo! Yay! All right. So now, Jack, integrate it for us. What do we get?
I don't know.
So we start with u squared.
To the fourth plus 2.
Oh, you're only going to add one. Just one. Just one little guy.
Oh, just one.
Oh,
Yeah.
I thought you were like.
All right. And then Miranda, sub back in for us.
Help.
I was gonna take like a 1/3 out and then put x squared plus 1. 1/3 times.
Oh, yeah. Okay. Like this?
Yeah.
Nice. I like it.
Or you can put it at the top.
Wait, what happened to the du though?
You could also do it like this. What happens? Do you remember when we perform the operation? So you could have it either this way or this way. When you perform the operation, the operator disappears, right? When you take the square root of 64, the square root symbol disappears, you're left with an 8. When you integrate the integral symbol and the d, whatever you're integrating with respect to, so in this case, if we're integrating with respect to u, the du and the integral symbol will disappear. Okay? Cool. All right, what about this one? Let's see. All right, who do we start with? Miranda, Naomi. What's my u? Yes. Mackenzie, what's my du? Yes. All right, Sierra, you want to rewrite it for us in terms of u?
Is it 5 square root of u?
Ooh, careful, where'd that 5 go? He got lumped into the...
Is it square root of u
Yeah. Can I write it to the 1/2 since we're going to integrate? Is that okay?
What if
Okay.
I put du first?
Don't do that. They do that in, who does that? In physics, they do that.
Mr. Childs.
Yeah.
Mr. Childs. He does.
I don't know why they do that. They do, though.
Wait, do what?
They put the du first. I don't know why they do that. So then now, what would we do? Sammy, go ahead and integrate for us.
Is it u over 3 halves?
Yes.
Do you multiply by something?
Yeah. Yup.
So 2/3.
Yes.
This should be a memory thing.
Plus Glevis. Who did you remember? Yes. Glevis is hired as a babysitter forever. Yes.
No!
She'll never forget the kids. Eleanor, put it all together for us.
Cindy, multiply 3 over 2. I don't know what you're doing. Oh, that's my bad. I did it wrong.
That's
Wait,
down.
no, you multiply 2 over 3 times 1/5, right?
No, you got this here, right? And we're kind of just like cleaning it up.
You don't have to do anything with the 1/5.
Where's the 1/5?
You're supposed to divide the
1/5.
5 divided by du.
Oh, I see. So you would do that if there was no 5 here. Then you're like, oh, there's no 5 in there. I'm going to put the 1/5 out front. But since there's a 5 in there, the du can absorb him too.
But you just, what? How did my 5 get absorbed?
Look, check it out. So this is a good question. Again, a good question.
It like matches up with each other.
Look.
Even though it's like
So,
in different spots.
in this one, right? Take a look at this one. Shh, this is a very good question. Guys, this is a great question. So, in the original structure here, do you see a constant? No. I see x cubed times the square root of x to the 4th plus 1, right? So when you took the derivative of your u substitution, what constant cropped up? What did you get in here? A pesky little 4 that was not present in the original. Because he wasn't present in the original, you had to divide both sides by 4 so that way you could factor out that constant and deal with it at the end. No, you're supposed to if a constant kind of just comes up and it's not in the original integral. Then you must do that.
All square root problem.
But no, check it out, right? So in the one that we just did, when we took the derivative and we got a 5, it was okay because there was already a 5 there. And we didn't have to divide both sides by 5.
I'm sorry, I'm not doing that.
Oh, that's okay. So you're just plugged back in for you, right? So in u's spot, I have a 5x plus 1 to the 3 over 2.
Jason's jiggling too much.
Yeah?
No, yeah, you're
Yeah? Okay.
What if I factored the 2 out to the 5x plus 1?
What if I factored the 2 out to the 5x plus 1?
Like I did
Huh?
10x plus 2. Oh,
You
that
can't
wouldn't
do
work.
that. No.
Don't tell me.
Who's going to tell him? He's under a square root. You can't do that. I'm glad you asked, though. All right, let's look at question 4. We stopped at Eleanor. We're going to Colin. Colin, who is you?
U is 1 plus 2x.
Yeah. You. Okay, so what is the derivative, Stevie? Du.
2dx.
Okay. So now, Eleanor, check it out. I got a 2 and a dx. So I'm going to look back in the original and be like, is that constant in there? He is. I don't have to divide.
No divide if there's a constant, but if there's an x, you divide.
If the constant you need is in there, then you don't have to divide. Because sometimes the constant that you don't need is going to be
I don't get that one.
We'll get there when we get there. But just see that there's a 2 dx. There's a 2 dx. I'm good. Everyone's spoken for as is right now, okay? All right, Chase, rewrite him in terms of u.
U to the 4th du.
Good job. And then St. John, integrate.
So you add 1,
Mm-hmm.
and then you divide by 5.
Mm-hmm.
So the u fifth
I like less.
5.
And then who is left in the hot car that you must go save? Plus C.
Connor.
Connor, go get him. Okay. Now-
Come!
Jason, can you rewrite this with x's, please?
1 over 5, and then 1 plus 2x all to the 5th power plus Connor.
Plus Connor. There he is. He is safe and out of the car. When you cited Ben
He said that. He said that.
Oh,
He
there's
said that.
more? Oh, man.
This is literally the same as before,
Can I say Kanye?
except now we're playing around with constants that kind of spawn in, and we got to figure out when we have to divide or not. So this is your page. Go to Eleanor's page. This is Eleanor's page.
Hi, Eleanor.
Page 12. Hi, Eleanor. We're on Eleanor's page.
Wait, why is this her page?
Because this is the great question she kept asking me. All right, here we go. So, where did we stop?
Oh, I think I was.
Just now.
Connor!
Yeah.
Who's you?
Probably like 6x minus 5.
6.
Who's DU, Jack?
6. DX. Why do you use a D? Does D seriously stand for with respect to?
It's the it's the differential.
That's not how
So,
you spell that.
let's talk. What?
You know, there's no D in there.
What? What?
Eleanor, okay, I'm gonna keep bugging you because I feel like you're very brave and good at asking questions. So, look at here. I have 6 DX. Do you see a 6 in the original?
Your name is no. It would have been.
No, right? It would have been over here if you did, right? And he's not.
Yeah.
So, what must you do now?
Not divide.
No, now you no, now you have to divide. He's not there, so you gotta divide, okay?
Then so you're really trying.
You are. No, I love it. I love it. Okay, you got this. All right. So now, what do I do now? I take that 1/6, I put it out front. Who did we stop with? Miranda. What should go in my integral?
Making it clap over here.
1/2.
D U
Oh, DX.
du. There you go. Naomi, integrate for us.
And then you flip the switch. It's gonna be 3 to 2 over 3 to
Naomi, integrate.
2/3.
Yeah. Whoa. Hold on. What is that?
Is he making it clap again?
He's
Making it snap.
this place is a prison. Okay, so now we have integrated, and we're gonna
This
put,
isn't back to prison.
we are now going to put X back in for you.
I just scored a touchdown. I got it right. No, I didn't.
Did you score a math touchdown?
I wrote my final answer without the U.
Oh, no.
Mackenzie for the win. Who is the? Ooh, this is a little tricky, maybe. Who's you in this one?
You're calling a student of yours baby?
Mackenzie DeBaby Mason. What is the derivative? What's the derivative?
4x cubed dx.
Okay, so let's take a look at this, right? Sammy, in the original integral, do you see a constant of 4? No. Therefore, you must. There you go. Good job, Sammy.
But when we create the new integral, do we still
I don't
the
know.
x to the third?
Yeah, so check it out, right? This gets absorbed by the du.
I don't get how these things get absorbed.
Absorbed. It's, remember when we were we're working backwards, so we got to think backwards. So you kind of got to plan ahead, right?
Like, who's absorbing these numbers?
It's just from when you take the derivative of something, which with a composite function, there's going to be a multiplication by the derivative at the end. So what you're doing is you're looking for that multiplication by the derivative in the original integral, and then using u substitution to kind of put it all back together to get back where you needed to go.
Excuse me, could you like act relatively normal?
So now we have 1 to the 4th,
Please?
and then who did we stop off at? Glavis. Rewrite this for us.
What?
Boom. Eleanor, integrate for us. So we have u squared. So you're going to add 1 and then divide by it.
Oh, so it's gonna be plus 1, so it's gonna be 3 divided by 3. It's gonna be
U to the third.
divided by 3.
Right. Can I just do that? Is that okay?
Yeah.
All right. Who did you leave in the car? Who do you need to go get? There we go.
Calvin is K. Oh wait, no it's not.
Colin. Get my Get my final answer for me. Okay, fine.
Yeah, I have it. My answer.
All right. What is it, Colin? You got it.
1 over 12.
I got cool cash
X
though.
plus 3. Make 2/3 plus C.
Good job.
Okay.
Okay. All right. Steve A. Oh, are you busy? Are you helping Chase?
Yeah.
All right, we'll skip you. Are you good? Do you know how to do this? Okay. St. John.
Yeah, I'm paying attention.
St. John, you're up. St. John.
Alright.
Time's up, St. John.
U equals T squared plus 2.
Would you like a drum roll?
Jason, DU is what?
2T.
Who did you forget? Oh, wait, I almost wrote it for you.
DX. TT. Sorry.
Yeah, there you go.
I'm used to the X.
Connor, make a judgment call.
We gotta divide.
Yep, we got to divide. Good job.
Yes, ma'am.
Okay. Jack. What? Write the integral for us if you dare.
1/2 of the squiggler.
That's a
And then you'd be doing the square root of TU,
Uh-huh.
you're the 1/2,
Mm-hmm.
and then plus du. No, not plus, just du.
I got you. All right, Miranda, integrate for us.
1/2 times 2u to 3/2.
Boom.
More x
Yeah. And then
Darnie is a minus.
Nah, Naomi's got it. Here we go, Naomi. Bring it on home.
What's it gonna get?
Very nice.
Yeah, I don't think it's gonna happen. Let me take off my shirt.
No, no, no.
Will we have to solve for C eventually or no?
Yeah. Yeah, that's a great question. So St. John was like, what if we had to solve for C? Well, let's think about how we would write this
Haven't we been doing that
in such a way. Yeah, but not with stuff this complicated, right? But if we wanted to, you would have t squared plus 2. And what do we know about stuff to the 3/2 power? One whole thing of them comes out front and the other is left under the square root. Do you guys remember when I've showed you that proof a few times? No? Okay, check it out. So you would have t squared plus 2 to the 2 over 2 times t squared plus 2, oops, to the 1/2.
How'd you get 1/3?
Because when you multiply like bases, you add the exponent. So couldn't you decompose them in the same way?
I thought you would have like done the to the 3rd power under the square root.
Oh.
We gotta do
And then this would be over 3 plus c, and then you could figure out whatever conditions you had in the original.
I need to see how we got
I know just the place.
The 1/3. Where? 1/3 what? Oh, yes, 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 yes. So it was 1/2 out front, and then we multiplied by the reciprocal, because that's the same thing as dividing by the 3 over 2. The 2's cancel, you get 1/3.
I got 3/4.
How'd you get that?
I did.
You would have 1/2 divided by 3 over 2.
3 over 2.
Okay, so look, if you wanted to divide by 3 over 2, this is what's actually happening. 1/2 times 2/3, because you keep change flip, and then these reduce. So that's why you must, if you're going to skip the step of manually dividing, you got to just multiply by the reciprocal, okay?
I wasn't watching.
Yeah. Great questions. You guys are locked in. I am proud. I am proud. All right, let's go to number 10. Okay. So I'm going to show you guys how to do number 10 because it's a little sneaky, but then when you see it, you're like, all right, I'm good. Okay, so the inner function to me is the ln of x. And the reason why I picked that as my inner function is because the derivative of the ln of x is 1 over x. So that's how I know that 1 over x is going to end up getting in there. That's what I mean by choosing u such that its derivative is present in the original integral. Okay? Perfect. So I'm going to let u equal the ln of x. Du is 1 over x dx. And then now I'm like, oh, this is 1 times, or like 1 over x times that. This is dx. So now what's my u substitution? U to the 10th du.
Oh, it's easy.
Yeah. And then now it's just u to the 11th over 11. Hold on, my 11s look like 4s. Hang on. U to the 11 over 11 plus c. And then I sub back in the ln of x to the 11th over 11 plus c. Come on, let me highlight my answer. I'm frozen.
Mic drop right there.
Can you guys try number 9 on your own while I wait for my computer to come back to life? Sorry, I'm
Indeed, I can.
skateboarding with a raccoon and it's kind of in the way, but just work around me.
Yeah, why'd you do that?
My daughter picks them. When I make a worksheet, I let her put whatever one she wants in there. I don't know, right? Why is it even an option? Yeah.
The raccoon's gonna fall off.
That's the real question.
What is the raccoon
She
like?
always picks like the animal ones.
Hear
I
me
don't
out.
know.
What if like, the animal walked forward and got ran over?
What?
What if like the raccoon like walked forward and got ran over? Like what happens then?
Or just turn around and bit me. Ah.
Did
That should be the real
Did
Bitmoji.
she pick the
It should
one
be
with
like a raccoon
dinosaurs?
getting run over.
Yeah,
Did
she
she
loves
pick the one with
dinosaurs.
dinosaurs?
Loves dinosaurs. There you go.
They should be like one where like the raccoon getting run over. So like honestly.
Why are your pants so high?
You just noticed that?
What do you mean?
He was up there the entire time.
Oh God. Okay.
Wait, I have a question, Connor. Is it still better than the track shorts, or is it worse now?
Yeah.
I mean,
You should
of
wear
course
some.
they
I
are.
would actually rather wear this than track shorts.
All right, guys. Wait. Join me for this quick little aside. Should I divide by a -2 in this case? What do you think?
Yeah.
Yes, ma'am.
Do you? Why?
Because
Because
there's
I
no,
did it.
There's no other two.
There's no -2 in there. Good job. Cause I did it.
Because I am him.
I hate the division thing. It makes you really throws my game off.
That's okay. You're gonna get there.
That's okay. It's supposed to.
You're gonna get there.
You got this.
Wow.
You're welcome.
Okay.
I'm a very good supporter. Aren't I?
All right, so I would have 1 over the square root of u, so I'm going to rewrite that as u to the -1/2 now, okay?
Okay.
Now I would integrate. So these are going to cancel, and I would get negative square root of 1 minus x squared plus e. Oops, I thought that was a highlighter. There we go. All right. Is that it? Yeah, you guys can start your homework. Woo.
Actually,
Did we?
paused.
Oh no!
Damn it,
I
Miranda!
need to practice.
Yeah.
That's what the homework's for.
I'll do number 8 with you real quick. You guys can do your homework if you know.
Who said that?
Come on, guys. Mess up.
My pen died anyway. Oh, there we go. It's back. It's back. It's back.
I don't think it's meant to be.
It might not be.
Wait,
Eight
so
stands for.
basically, whenever it's on the bottom, we have to match it with the top, and then whenever it's on the top, we have to match it with the bottom.
Can you say that again?
So since u equals to, like the bottom, do
Hmm.
we have to match like the derivative of u to the top? This is just back from bottom. So you don't say it's gonna get in. So
I think that's a good rule of thumb with the exception of when you have ln's, because remember his derivative is in the bottom. So is that what you mean, kind of?
Yeah,
Yeah.
I think so.
Cool idea.
I think so.
Oh, that doesn't look like it too. All right, so this is gonna be 1 over u cubed du.
Where do you put you
Huh?
in? Where do you put you in?
I don't think you do.
Yeah, there's no U for first.
Right.
No, those were like warm-ups, but I feel like we wouldn't have had time to go through all the stuff I wanted to do today, so we skipped them. You can go back and do them if you want, but I'd rather have you guys practice this.
Just do no use, right? Just do normal.
The first couple are no use. You can like, okay, so like if you hold on.
Yeah. No use, Sinjin.
That makes sense. I was sitting there like, where the hell can I put this in?
No use or no for the first couple.
Alright, I gotta relearn.
National shower in class 6.
No,
What are you doing this?
it's frozen. It's making my life hard.
Theater across the room.
We'll do it on the board. It's fine. Forget this
Is he
thing.
singing in the shower?
I think it's because I'm taking a video. It's just too much going on.
4x to the fifth.
I'm sorry. I'm fucking.